Welcome to Electrical Solder Recertification Training. The purpose of this training is to provide a training manual for electrical soldering recertification. This training has been developed to ensure compliance with 9-4400. This training covers how to solder electrical components to engineering and quality requirements. At the end of this training, you will be able to define soldering terms and definitions, understand the general requirements of soldering practice, identify and use soldering tools and equipment, explain the proper procedures to meet electrical solder workmanship. Additional training shall be required when defined by specification or other defined requirements. The following applies to all solder operators. Solder operators must be trained to comply with 9-4400 and applicable specifications. Solder operators must pass a standard vision test. Certification shall be revoked when the operator does not meet workmanship standards or does not pass any recertification test. Recertification is required every 2 years unless specifically waived by the quality manager. The following general requirements applies to all solder operators. No eating or drinking at the workstations. Workstation lighting must be at least 100-foot candles. All materials must be properly identified and specified in the work instructions. All soldering is 100% inspected. Operators should submit only known conforming products to inspection. Inspection is not to be used as a screen for known inferior workmanship. Hands should be thoroughly washed with soap and hot water prior to eating or smoking to prevent ingestion or inhaling solder, flux, or solvents. Work areas and tools shall be maintained in a clean and orderly condition. All dirt, grease, flux, solder splatter, chips, or other contaminating foreign material shall be promptly removed. Documentation essentials. The work instructions must be available. The route sheet must be complete, and any documents needed for the job must be available. If a conflict exists between the instructions and the drawing, stop work until they align. All specification requirements must be met. All materials and tooling must be properly identified. Let's review soldering terms and definitions. Bridge, a buildup of solder between parts, part leads, and/or base materials. Conductor, a lead, wire, or printed path serving as an electrical connection between terminations. Conformal coating, a thin electrical non-conductive protective coating which conforms to the configuration of the covered assembly. Encapsulating compound, an electrical non-conducive compound used to completely enclose and fill voids between electrical components. Eyelet terminal. A terminal with a hole through which wires are routed before soldering. Fillet. Material buildup between two side-by-side surfaces. A solder fillet between a part lead and a solder pad. Flux. Material used to remove oxidation from parts before soldering. Promotes good wetting. Heat sink. A device with good heat dissipation attributes. Conducts heat away from an object. Hook terminal. A terminal formed in the shape of a hook. Interfacial connections. A conductor connecting conducive patterns between opposite sides of a printed circuit board. Mencus. A protective coating on a part found on pocketbook or tombstone capacitors. Messling. The lamination of the base material of a printed circuit board. Discrete light-colored spots or crosses at the weave sections of the laminated base materials where the glass fibers have separated, usually caused by excessive heat and/or material stress. Pads. A termination area on a printed circuit board. Pits. Small holes or sharp depressions in the surface of the solder joint. Plated through hole. A hole on a printed circuit board that is plated on the inside diameter to provide electrical continuity between circuits on each side of the board. Wetting. The ability of solder to combine with metal. The most important element of soldering. Printed circuit board. A pre-designed circuit mounted on a thin, rigid board. Solder cup. A hollow, round terminal into which wires are placed and soldered. Soldering. The joining of metallic surfaces with solder without direct fusion of the base metal. Staking compound. An electrical non-conducive adhesive used to anchor a part. Stress relief. A way to minimize the stresses to the soldered termination or part. Terminal. A tie point for making electrical connections. Tinning. The coating of a surface with a thin layer of solder. Turret terminal. A round post-type groove stud around which conductors are fastened before soldering. Wire overlap. Occurs when wire or lead is wrapped greater than 360 degrees and does not remain in contact with terminal post. Wire overwrap occurs when the wire or lead is wrapped greater than 360 degrees and remains in contact with the terminal post. Let's review solder defects. Porous solder joint. A solder joint containing holes. Rosin solder joint. A solder joint which contains trapped flux. Contaminated joint. A connection that has inclusions, flux residues, cotton fibers, foreign matter, dirt on or embedded in the surface. Lifted pad. A separation of the pad from the laminate of the board, caused by excessive heat, pressure, or time while making the solder joint. Fractured solder joint. A joint which shows evidence of cracking within the solder. Cold solder joint. A solder joint exhibiting poor wetting and insignificant heat usually appears frosty and granular. Icicle, a cone-shaped peak or point of solder usually formed by the premature cooling and solidification of solder upon removal of the heat source. Nick, a cut in the wire extending into the base material. Wicking, the flow of solder in and around a joint. Non-wetting, the inability of solder to combine with metal. Bird caging, a condition where the natural lay or twist of the wire has been disturbed. After stripping the wire, the layers of the strands may be restored. Blowhole, a surface condition where the entire inner surface is not visible. Delamination, a separation of layers of base material of a printed circuit board or separation of conducive pattern for those layers of base materials. Dewetting, a condition which results when molded solder has coated the surfaces and then recedes, leaving a thin film of solder. Base metal is not exposed. Disturbed solder, a solder joint that saw movement during solidification. Excessive solder, a condition where the contour of the elements of the joint are completely obscured, or one where solder overflowed beyond the confines of the joint. Rose nose pliers are used to form hooks and bends in wire. Prevents damage to the wires. Needle nose pliers should not be used to form hooks or bends in wires. Surface may cause nicks and/or cuts in wire. Thermal scrippers utilized to remove insulation from stranded and solid conductor wires shall be of a type that can be regulated to provide the required temperature. Temperature controls shall be adequate to preclude damage to the wire or insulation not stripped from the wire. Mechanical scrippers are utilized to remove insulation from stranded or solid conductor wires and may be of the hand-operated or automatic high-volume machine type. Hand-operated scrippers shall be of a fixed die configuration. Automatic high-volume machine scrippers shall be of a type utilizing either fixed dies, dies adjustable to collaborated stops, or roller cutters adjustable to collaborated stops. Dies, whether adjustable or fixed, will be maintained to assure consistency in sharpness and even cuts without damage to the wires or unscripted insulation. Wire preparation. Operators should visually inspect the wire after script to ensure no damage has occurred. The insulation must first be removed from the wire to make an electrical connection. Stranded wire has many individual conductors inside the insulation. Solid wire is a single strand of wire, also known as the lead. The insulation may be of the Teflon type, or in the case of magnet wire, a varnish material. Insulation. Insulation damage may be allowed provided that insulation shall not have uneven or ragged pieces of insulation greater than 50% of the insulation outside diameter or 0.04 inches, whichever is more. Insulation may have slight discoloration from thermal stripping, but shall not be charred. Insulation deformation shall be allowed provided that insulation shall not have cuts, breaks, cracks, or splits. Insulation shall not be melted into the wire strands. Insulation thickness shall not be reduced by more than 20%. Workmanship. It is important to learn the proper technique to avoid damaging the wires or conductor. When scripting a wire, any damage can create an undesirable condition. The following are examples of poor workmanship. In this image, the wire was not soldered to spark gap terminal. Exciter passed in process tests, but the exciter failed at final test. This picture illustrates a nick in white wire and no insulation gap on red wire. This picture illustrates an example of a transformer lead that was not soldered to transistor terminal. This image represents 10-397050-5, failed final electric test for excessive current. The lead from coil was not attached to feed-through terminal and was touching input cover. Regarding these examples, the exposed body of the capacitor came in contact with the chassis, causing the exciter to draw excessive current. The negative impact of poor workmanship is reworked hours, scrap materials, delayed delivery to our customer, and escapes to the customer.